Have you ever pondered about the mysteries that lie beyond our skies, particularly about neutron stars? In the vast expanse of the cosmos, neutron stars hold a unique and intriguing position. These celestial bodies are not just your average stars, they are cosmic anomalies that continue to baffle and fascinate scientists and astronomy enthusiasts alike. Born from the explosive death of other larger stars, these compact objects harbor more questions than answers. Imagine a star with a mass greater than our sun, yet confined to a sphere just about 20 kilometers across. That's a neutron star for you. Their incredibly dense and fast-spinning nature, coupled with their strong magnetic fields, make them one of the most enigmatic entities in the universe. Their existence challenges our understanding of physics, pushing the boundaries of what we thought was possible. So buckle up as we delve into the extraordinary tale of neutron stars. The birth of a neutron star is a cosmic spectacle, a phenomenon that occurs under extreme conditions. Our cosmic story begins with a star, but not just any star. We're talking about a behemoth, a star at least 8 times the mass of our sun. This giant star spends its life fusing hydrogen to helium, helium to carbon, and so on, all the way up the periodic table until it forms a core of iron. But there's a problem. Iron doesn't like to fuse. It's the end of the line. The star can't generate any more energy from nuclear fusion. And without this outward pressure to balance the inward pull of gravity, the star begins to collapse under its own weight. This is the beginning of the end. In a matter of seconds, the core shrinks from roughly the size of Earth to a sphere only about 20 kilometers across. This rapid collapse triggers a supernova explosion, one of the most energetic events in the universe. It's so bright that it can briefly outshine an entire galaxy. But our focus today isn't on the supernova itself. No, we're interested in what's left behind. The core of the star, now incredibly dense, continues to collapse. The pressure is so intense that electrons and protons are squeezed together to form neutrons. This is where our neutron star gets its name. The collapse stops when the core becomes so dense that the neutrons are packed as closely as they can be, a state known as neutron degeneracy. The star now has a density billions of times greater than anything we can imagine. A sugar cube-sized amount of neutron star matter would weigh as much as a mountain. And that's how a neutron star is born. It's a stellar graveyard, a monument to the death of a massive star. But it's also a testament to the incredible forces and extreme conditions found in our universe. Thus, in the fiery aftermath of a supernova explosion, a neutron star begins its life. Scene script. Neutron stars may be tiny compared to other stars, but they pack a punch in terms of their unique properties. Imagine compressing a mass greater than our sun into a sphere with a diameter of approximately 15 miles. That's the density we're talking about when we delve into the world of neutron stars. To put it into perspective, a single teaspoon of neutron star material would weigh about 1 billion tons on Earth. Yes, you heard it right, 1 billion tons. This mind-boggling density is a result of the intense gravitational forces at play, which compress the star's matter to the point where protons and electrons merge to form neutrons, hence the name neutron stars. But the peculiarity of neutron stars doesn't stop at their density. These celestial bodies are also some of the fastest-spinning entities in the universe. Some neutron stars, known as pulsars, can spin at rates of up to several hundred times per second. This rapid rotation, combined with their extreme density, results in a centrifugal force that flattens the star at its poles and bulges it at the equator, giving it an oblate shape. And if that's not enough, let's talk about the magnetic fields. Neutron stars possess the strongest magnetic fields known in the universe. These magnetic fields are 1,000,000 billion times stronger than Earth's. The interaction between the star's magnetic field and its rapid rotation creates beams of electromagnetic radiation. When these beams sweep across the Earth's line of sight, we observe a pulse of radiation, hence the name pulsars. What's truly fascinating is how these properties, their incredible density, rapid rotation, and strong magnetic fields, make neutron stars unique among celestial bodies. They are not just another type of star. They are cosmic laboratories, allowing us to explore the laws of physics under conditions that simply cannot be replicated on Earth. In the grand tapestry of the cosmos, neutron stars truly stand out due to their remarkable characteristics. Neutron stars, despite their small size, play a significant role in the grand scheme of the universe. Imagine these celestial bodies as cosmic laboratories, conducting experiments on a scale that's simply impossible on Earth. In their extreme environments, they challenge our current understanding of physics, pushing the boundaries of what we know and believe. Neutron stars are critical to our understanding of stellar evolution. As the remnants of supernovae, they offer a glimpse into the life cycles of stars, shedding light on the processes that lead to their formation and eventual demise. But their significance doesn't stop there. By studying these cosmic powerhouses, we can potentially make new discoveries about the universe. Their extreme densities and magnetic fields might even help us explore the nature of matter and energy at their most fundamental levels. Indeed, neutron stars are more than just celestial bodies. They are cosmic laboratories that hold the key to understanding the universe. Our journey in the shadow of black holes, exploring the extraordinary tale of neutron stars, has been quite an adventure. We've journeyed from their violent birth as supernovae explode, leaving behind these celestial remnants compacted to a density so high, a single teaspoon would weigh as much as a mountain. We've delved into their unique characteristics, their rapid rotation and strong magnetic fields that create pulsars, the cosmic lighthouses of the universe. We've discovered their critical role as cosmic laboratories, enabling us to test the very laws of physics in ways we could never do on Earth. These enigmatic stars, so different from our own sun, yet so integral to the fabric of the cosmos, continue to fascinate and inspire us. As we continue our cosmic journey, let's remember that there's always more to discover, especially when we gaze upon the stars.